everyone. Today we'll be talking about lowering Gen AI adoption barriers with OPEA. What's OPEA? OPEA is the Open Platform for Enterprise AI. It's an open source project. I'm Malini Bandaru with Intel, a cloud software architect, and my colleague Iris Ding is also a cloud software architect, and we're super excited to be sharing this information with you. What are we going to cover today? We're going to cover Gen AI adoption barriers. The challenges that are there are many. We'll talk about OPEA, give you a better idea about what it is and how you could get involved. So, what does a typical Gen AI application workflow look like? This looks like an eye chart, right? I mean, there's several boxes over here, and there are things like ingestion and guardrails and embedding and so on and so forth. So, we'll take a closer look at this. And why do we need to look at this? Because generative AI is not just about a large language model or vision model or audio model. There's several steps involved. Particularly, a model is something that you have trained with a lot of data and might be a year or two old. So if you're asking some current information like what's the situation of a war in the Middle East? Or is there an earthquake somewhere? Or is there a new drug development going on? You won't get that information by just asking the large language model. You need to provide it some current data, and sometimes it might be proprietary. Like if you want to use it in the context of your company, you might have some bug databases, some proprietary documents, some research information. So you need to give that information to your large language model to then digest it, comprehend it, summarize it, and give you the information you require. So a typical RAG pipeline has a data ingestion phase. It could be video, audio, graphs, tables, CSVs, whatever. It goes into another component called an embedder. And I'm going to use a very technical term here called chunking. So, chunking is when you break that image or that whole book chapter into smaller sections, like maybe a sentence or a sub sentence or a phrase or a whole paragraph, whatever. So, you can have hierarchical chunking, you can have sentence level chunking, and you also want to capture semantic information the user has provided while creating it. Like if it's an HTML title, subsection, heading, etc. So that's the value of the embedded. Breaks things up and then it goes into another format called a vector. So that vector is a representation of that chunk in a numerical format, and they save it typically in a database which we call as a vector database. These vector databases allow you to index stuff, retrieve them very quickly, and there are many ways of indexing too. So that's this little component out here. So when a user request comes, let's say user query comes in, their query is also chunked, also made into a vector, and then you retrieve from your vector database other entities that are similar. Once you've done that, there's a retrieval ranking process. There might be 10 things, but maybe your criteria is like, give me the most current information about some research or the situation of a war somewhere. So the retrieved documents might be reordered based on how current they are, the most recent first type of thing. All that stuff is then combined with your original query and then sent into the large language model before generating a response. But even that response is not given to you directly because it could be choppy, it could be having bias, it could be negative. So that's where something called a guardrail fits in, which does this sort of sanitization, checking for bias, checking for validity, for hallucinations. That's a term that you use in Gen AI when you're creating information that you expect in some format. And then you send it off to the end user. So this is the typical RAG pipeline. And something that you also might want to have is some user feedback like, did this answer help me? No. Was it on point? Yes. So on and so forth. So that can be used to fine tune your models. It's a feedback loop. So there's trading involved. So given that this is a typical Gen AI pipeline, let's look at what our enterprise needs are because enterprises are eager to unlock the value of Gen AI in their companies. But what are they concerned about? They're concerned about security. They don't want you to go and use some large language model and send it your proprietary data from inside your company. They also want it to scale. Does it meet the needs of their 10 employee base or a 10,000 employee base or a 100,000 employee base? Is it reliable? Can you always say, I need document summary, and is this service available? So that's the reliability aspect, and nobody wants to break the bank. So cost is also a very serious consideration for enterprises. It's one thing if you and I want to just go test something out once or twice, but when you have hundreds and thousands of employees using it day over day, you want the cost to also be curtailed. So, with that sort of introduction, I bet you would guess what Gartner says are the three top challenges. Their technical complexity, you saw that whole flow chart. There's the cost angle when you want to provide it at scale. And there's another very big thing, and that's talent scarcity. We don't have enough engineers with cloud expertise, with AI expertise, and you need both of these to deliver these enterprise size solutions. What typically helps us in such scenarios? It's an open ecosystem. I mean, everybody can't be an AI expert or a cloud expert, but once you start developing things in open source, you can look at that. It becomes pedagogical. You can study it, you can understand it. There's no cost to trying to use it, and you can contribute, learn, and then leverage it. So, open ecosystems is the way to go. So we at Intel decided to address this by starting an open project, and that's where we have Open Platform for GenAI. The OPEA vision, and I'm going to just read it out to you because we really nailed this, I thought, when we developed it. It's about enabling enterprises to develop and deploy GenAI solutions powered by an open ecosystem that delivers on security, safety, scalability, cost efficiency, and agility. So it's a mouthful, but our whole technical steering committee kind of like banged on this and developed this. So we're pretty happy with it. So where does OPEA live? The Linux Foundation, the parent of the Linux whole operating system, has a long reputation of open source, open governance, and hosting all these conferences, and of course the whole code base, etc. So we decided to launch OPEA under the Linux Foundation. It's part of the Linux AI and Data Foundation. And I have a link out here. So if you click there, it can take you everywhere you really need to go. Like, when are the meetings? Where are the meetings? What are the past meeting records? Where are the work groups? When do they meet? Which are the work groups? So let's take a look at those. So we have a developer experience work group, an end user work group, an evaluation work group. And when I say evaluation, it spans more than performance, because with AI, you also need trustworthiness. Are the answers it provides legitimate, valid? Is there bias? Like, if you were using an AI model to say, who do I give a loan to? Is it biased based on our race, gender, color, etc.? You don't want that sort of stuff. It's also about safety. Is it like, if you're giving it a prompt, are you trying to murder somebody or give me some poisons? Is it responding to that sort of stuff? So that's the safety angle. So evaluation will comprehend all these different scales. Then there's about community building. Are we hosting events? Are we inviting everybody? Are we inclusive? Um, and so on and so forth. And of course, with anything this new, and you can say AI is like 60 years old depending on who you're talking to, or you can say it's 5 years old depending on who else you're talking to, because of the advent of large language models and deep learning being more recent. It's all about research. You want to have open data, open models, and allow researchers and end users to try these things out and improve upon them. So research is a very critical part of it. And last but not least, security. You want to protect the model so that it's not exfiltrated or manipulated or modified and things like that. So currently, we have several TSC members, and what's important is where they're coming from. It's broad in its representation. So we have two hardware companies at this point on the technical steering committee. They're AMD and Intel. We have end user community, so that is Fidelity and Comcast. We have solution integrator vendors, so that's coming from CDW. We also have cloud expertise. So we have Justin from Docker, we have Logan from Llama Index. So that's the AI representation, and Melissa from JFrog, who's also interested in things like metrics and performance and so on and so forth. So we've assembled a nice holistic technical steering committee, and we've got started as early as May this year. So it's about 5, 6 months old. And let's get further in. Some of these people are already represented on the TSC, but there are several more, and there are already contributions from some of them. And one of them is from a guardrail company. So, with that, let's take a closer look at what do we have in terms of code. Whenever you talk about open source and you're an engineer, it's like, okay, where's the code? Vision is one thing, PowerPoint slides is another thing, but where's the code that I can look at, use, and improve? So the GitHub home is OPEA project. There's several sub-projects under it, and let's take a closer look at these. One is called the GenAI comps right here. These are containerized components. So if you were thinking like Lego blocks, these are the individual blocks, and then what do you use those blocks for? You make dinosaurs, dragons, boats, whatever. So these GenAI components are those Lego blocks, the little units that you'll use to compose your bigger solutions. What do we have there right now? We have inference engines there. So we have VLLM, we have TGI, etc. So those are the inference engines. But what else? When we looked at that earlier chart, remember, there were those different things like guardrails, there was the vector database, there was the data cleaning, processing phase. So that's where we have components like the vector database, embedders, re-rankers, guardrails, and something else that is relatively new are agents. So you might have an agent to go and say, retrieve all the charts related to growth in some company or market or something. And that agent will actually go look on the internet, retrieve that, and then come back and give it to the large language model to say, now you summarize it, sort of stuff. Okay, so we have components, but what about it? An important thing to reduce this adoption barrier is to provide sample pipelines for things like a chatbot. That's a number one use case. I mean, across industry. Like you want to go buy an appliance at Home Depot, you say, well, I want to buy a fridge. And then the chatbot says, so tell me what the dimension of the space in your kitchen, what color, what, how big is your family, and so on and so forth. And then it says, there's ABC, please choose. This is the price range type of thing. So a chatbot is not just for this appliance kind of store. It could be for solving a bug or for writing some code or suggesting some test cases too. So chatbots, so that's ChatQnA, and there are actually multiple variants of this ChatQnA. What if the input was in text based? What if it was audio? What if it was an image instead? So like you want to show it a picture of something and say, where can I buy this kind of drapes or something? Then there's document summarization. Then there's translation. So we all use translation, like, all our websites, we can just translate from English to Mandarin and so on and so forth. And something that's very, very useful since people have traveled the whole GitHub database of so many projects, we have code generation too. And then there's code translation. You developed it in Python, you want to see it in Go or something else. So now, apart from these two components that are very much AI pertinent, where are these workloads running? I mean, especially at scale. So they have to land in a cloud somewhere. And that's where Gen AI infra comes in. So here we have things that we are going to look at from an enterprise angle, like where can I run the workload? Is it like a nice component that I can just launch as a Docker, instance? Do I need to scale it across a whole Kubernetes cluster? And if I have a Kubernetes cluster, how do I integrate it with other things like tracing, metrics, analytics, then even things like audit trails, especially if you're going and changing passwords or retrieving something from some proprietary database. So we wanted to have all that in one place so that, you don't need an expert coming from elsewhere. So with that in mind, we have developed something called the Gen AI Microservices Connector. I'll get into more detail in a bit on that. But also all our solutions can run on Docker. So you can run it on a single node instance, bang on it, play on it, make sure your pipeline is what you want before you move it into a production cluster and scale and things like that. And then Our team has also a very strong cloud background apart from the AI background that other teams bring in. So we said, what about authentication? What about authorization? What about integrating with service meshes that out of the box give you all this metrics collection, audits, tracing, logging, and so on and so forth. And then we want to launch this in the cloud. So there are best practices there, like your containers should not have root access. You shouldn't be able to go and elevate your privileges and capabilities. Another very important thing is how do you deploy it and ease that deployment, and that's where the operator pattern comes in. So we've followed all those cloud best practices as part of our GenAI infra, including providing Helm charts and things like that. Last but not least, and I've touched upon this a little bit earlier in the context of guardrails, is how trustworthy are these GenAI pipelines. And a lot of it depends also on the actual models you use, because some models are better than others. Some guardrails are better than others. So, maybe you need to mix and match them. For instance, when you're sending in training data, you don't want people's phone numbers to go in. You don't want license plates to go in. So you want to blur all those sort of stuff in your training. But also when you're giving responses, you don't want to expose certain things that are proprietary. So all this is great code, but you need docs. And I'm happy to say over the last month, our docs have seriously improved with some awesome help from David and Tom on our team. So, as promised, I had said I was going to tell you a little bit about this Gen AI microservice connector, and that's part of our Gen AI infra sub project. And what its design goals, it's all about efficient deployment and management. So, when you're talking about a Gen AI pipeline, you want to manage the whole pipeline. So, you say, okay, here's my pipeline, and let's just pretend at this point it's like everybody, it's like noontime, everybody's seen some business report and they want to summarize it or something. So there's a high volume of users at that point. So you want this pipeline to scale to that user base. And that's a piece that our GenAI microservice connector, I'll call it GMC, helps you with. But another very important thing, you are in the context of one single enterprise, and maybe all of those or multiple of those pipelines in that enterprise are using, say, the Mistral large language model, or maybe even ChatGPT 3.5 or whatever. But if there's not enough action and users across all those pipelines, do I want to have three instances of, let's say, this Mistral model? Perhaps not. If they're all using the same model, let there be one service of it and let that be shared across all the different pipelines. And if the load increases, you can then, bump up the service, like through horizontal pod auto scaling, make two or more instances of it. So that's the sort of stuff our GMC provides you. Sharing of microservices, and you can have isolation too. So suppose if you have two competing people or teams on the same cluster and they have to be kept isolated, you can separate them by namespace and have the scaling happen within a namespace, the sharing happen within a namespace too. So we have an operator to install this GMC. We have the YAML file that's, of course, human readable that you can use to define. It also lets you dynamically change out the model you're using. And how does it do it? It has constructs in that YAML file that says, I want these steps to be sequential. I want this particular step to be a switch statement where I can say, I want to use Mistral, I want to use Olama or something much smaller or larger and so on and so forth. So we have a switch statement and we also have a parallel statement. And when does parallel come useful? Like when you have agents that have to go and retrieve things and come back and then summarize, when you have maybe multiple experts, like in a medical domain where you want to go to a real live doctor, then maybe model A, model B, and then summarize the input to help the patient or so on and so forth. So this model selection and making that switch statement and being dynamic, there's a super good value for that. Why? Because today there is no winner, no best model. Each model has its pros and cons apart from its size and so on and so forth. So when you're maybe like summarizing a document, say, okay, what if I use ChatGPT 4? Say, okay, this is what I got. But what if I used Mistral or what if I used an Intel model like our neural chat one? What is the response you get? So we today are doing that manual step of checking these different responses with different models. So we wanted to make that out of the box easily possible with this GMC. And last but not least, being the cloud team, being aware of all these common things that we need, we have enough support in there to just plug and play with whatever authorization and authentication scheme you have. We're using open source stuff there too, like Keycloak, which works with different, you could have used a Facebook or a Google or your home, your LDAP from your office kind of scenario for your authentication piece. And we have observability integrated, and we're going to put in more service mesh pieces so you can have things like traffic shaping. And of course, we want encrypted communication, could be mutual or one-sided, whatever you want, and bring in your keys. So before I hand off to Iris to cover the demo, let me tell you a little about the ChatQnA demo. On this very top left side is the flow. It's simplified. I'm not showing you all the microservices, but on the very left, you have the data processing step where you bring in your documents and then you chunk them, you make vectors out of them, and then drop them into a vector database. So this is the data preparation flow. And from this top portion, we come in with the usage. So a user comes in with a query. The query itself is also chunked and made into vectors. That's the embedding. And you go into the vector database at this point to retrieve vectors that are similar. So maybe you get a few of them, and after you get them, you have to reorder them based on their relevancy. The relevancy could have been most current or a most technical, whatever. Different metadata can be used to help us to order these. And there's sometimes even a model involved, even in this phase. So there's a machine learning model in the embedder, one potentially in the re-ranker, and then, of course, in the large language model itself. And here comes the response. Where the guardrails? So that's captured in this lower figure over here. So we have the data ingestion UI, the user input query UI. They all go to our UI server. We have a little gateway in there that routes things to the appropriate endpoints. So if you're doing the data preparation phase, it goes down here. If you're doing the prompt phase, you're going up here. I have two links here. So offline, you can still retrieve all this information. You can go to the demo just like how we set this up, and then the demo link itself. So if you just wanted to replay the recording. But what's really critical over here in the demo is that we're illustrating three things. What if you were doing chat Q&A with no augmenting with your own data? So no RAG part to it. So just sending your query and getting an answer from the LLM. And for instance, if you said like, who's the presidential candidates right now in the US, it wouldn't be able to answer, the right thing. It would have said, okay, there's Biden and there's Trump. If this language model had been trained, let's say 2 years back. But if you ask it today, after putting in all the latest, greatest news items, it'll say, yes, there's Kamala Harris and there's Trump. So you see how the answer will change. So the demo comprehends three things. One is without RAG, one is with RAG, where you uploaded your latest, greatest information. And last but not least, we had used in the middle phase one model and said, let's switch out that model and then see what the response is, how different they are. So with that, I hand off to Iris.
Hi, in this demo, I will show you how you can easily compose a GenAI application, for example, ChatQnA, using the GenAI components and the microservices connector under the OPEA project. For this demo, you will need a Kubernetes cluster up and running. It can be running on your local environment, or it can also running in the cloud. So it doesn't matter. Both should work. And then you should clone this GitHub repo. It's called the GenAI Infra. So this repo provides the cloud native support for the OPEA components. Under this repo, there is a key component called GenAI Microservices Connector, for short GMC. So GMC can help you connect and compose the GenAI application easily. You can follow this GMC deployment on Kubernetes cluster to deploy GMC on your environment. So for this demo, I already have GMC up and running in my cluster. So let's take a look. So you can see the GMC controller is already running there. And I also cloned the repo already. So under this repo, let's move to the microservice connector. So you can follow the README there for the detailed introduction and deployment guide. So under this directory, there is a config samples. So there are a bunch of examples here. So in this demo, I will show you the ChatQnA, but actually you can compose your own GenAI application using microservice connector according to your need. So let's move to the ChatQnA example. So in this demo, I will demo several scenarios for you. First, we will deploy ChatQnA application without RAG. So it means in the pipeline, it will only have the LLM part. So let's take a look. See here, there is no other component, just the LLM part. So let's first create a namespace to hold this example. So now let's take a look what happened after we apply this application YAML file. So you can see the GMC will provision the related services for you. So in this example, there will be a LM service and the TGI service. They will work together to providing the kind of Q&A capability for you. This component is called a router. It's a GMC component. It will help you connect your services and provide your entry point for the GenAI application. These services we are currently in this first no-rag demo. I'm using a model from the Intel one, but still it needs to download from the Hugging Face. So it will take some time. So while it is downloading the model and get this pod ready, let's deploy a client pod for the demonstration about how to access the application. We also do some preparation work, like export the related client pod ID and the access URL for the pipeline. Okay, let's take another look at whether the pod is ready now. Okay, great. You can see all the four services is up and running now. And we also can get the application status through the GMC custom resource. So you can see all the three services is ready and this gives you the access URL. So it's time for us to send a query, ask a question to this Edge Q&A example. So in this query, I'm asking like, who are the U.S. presidential candidates for 2024? You can see the answer is something like, the presidential election is still a long way far away because this model doesn't have the latest information. So this is the reason why it gave such kind of result back. So, it's time to enable RAG here to ingest the related knowledge to the China Q&A application. So now, let's stop here for this question and let's move to the with RAG part. So we will use this China Q&A example. So you can see here, this ChatQnA application has a bunch of more steps. So like they have embedding, retrieval, re-ranking. So you can ingest your knowledge database. In this example, it's a Redis vector DB will host all these knowledges, and then finally this step is the same. The LLM part we didn't change. So let's apply this part. So let's see what happens. So you can see the GMC will help you provision all the related additional, the newly added components into the namespace. Like he will enable embedding, Redis vector DB, re-ranking. But you can see here for the TGI service, for the LLM service, they will reuse. So it can detect, this service it required has already been there. So it will just reuse the resource. So this is very, very convenient and resource efficient for the GenAI application. So yeah, it will take some time to provision this environment. So meanwhile, let's try to find some latest information about the presidential election and inject it into the data prepare service. Okay, now all the service is up and running. So let's inject a knowledge to this RAG-enabled application. So actually here you can see I'm using this this link. So it gives the introduction about the presidential candidates. So let's index the knowledge here. Okay, so the data preparing succeeded. So it means the current ChatQnA application should have knowledge for this question. So now let's ask them again. So now it will give you a very accurate answer, like the former President Donald Trump and the Vice President Harris will be the candidate. Yeah, this is the effect about the RAG. So I mean, if your model is hard to update, you can enable RAG to get the latest information and make your Gen AI more accurate. Next, I will demo the third scenario, switch or update LLM model. So this is also a very frequent requirement. For example, the model has been updated in your environment, and or you want to try different model to see which one works best for your need. So in this case, you can easily modify the pipeline to modify the model it uses. So let's take a look. So you can see, I actually in this step, I replace the model with the Hugging Face mixture one. So let's try to. So this is the only different from the original pipeline. For example, if you take a difference here, so this is the only difference. Okay, so let's apply this new version again. Still, GMC will help you to update related resource and reuse. You can see here all these original components like embedding, Redis, all is using the doesn't influence. It's still using the original version. But for the TPI, since I updated the model, it will provision a new one. Meanwhile, it will make sure it will not break your service. You can see the old version it's still running while the new one is downloading the model and get ready. So now let's try to send the question again. Yeah, since the knowledge is still there, so it can give the accurate answer for the presidential election. Let's try another question. So what the question is, what is the capital of the USA? Yeah, so it will give you answer as well. So and now you can see um, the the TGI part has been updated to using the latest the newly updated model. So you can see it's here. This one is terminating and this is up and running. It's just up and running for about 1 minute. Yeah. So the GenAI microservice connector has a bunch of features as well. Yeah, feel free to try. And thank you very much.
Thank you, Iris, for the demo. And I'm sure you have a lot of questions. And please feel free to check out our demo link and pause and look at it some more and look at the code to answer your questions. You can also use our Slack channel to get in touch with us. So we have our OPEA website, our OPEA wiki, etc. So if you just go to opea.dev, it leads you to everything, including that initial RAG flow type of stuff, the wiki pages, our technical documentation, and then all our community events. So very critical to community is everybody, you, me, and how we all come together and crowdsource our future. So coming up on Monday, this is like 2 days away. We have our October hackathon. I don't know when you'll be listening to this, so whether it's before, after, or during. But during this October hackathon, we have several issues that we have filed where we would like your help. Some of them are marked as beginner issues, and some of them can be more involved. So, after you get mature with this project, more comfortable with it, you can attack the meatier issues. So we would like some deployment scripts to run OPEA on different cloud service providers. Currently, we have a few for AWS and for our own Intel Developer Cloud. In our Intel Developer Cloud, we have our Intel Xeons, like 3 generations of them, and we have an Intel accelerator called Gaudi. So we have our Gaudi 2s, and just 2 days back, we announced our Gaudi 3. So it's Intel's GPU accelerator. We have some use cases in there. To be precise, we have 16 use cases, and I'd alluded to them earlier, like ChatQnA with audio, video, etc., document summary, translation. But please feel free to contribute your own use cases, something that you feel is compelling and common and necessary, and let's integrate it. So more the merrier. And another very important thing is all those components I mentioned. There's several of them, but let's talk about vector database, for instance. We have Redis in there. There's Milvus too, and Milvus is one of our partners, but the list doesn't stop there. There's several other providers like Yellowbrick, Neo4j, which has its graph database, and so on and so forth. So with time, we want to integrate more and more components, more and more Lego blocks, so you can make mixed and match these and bring your own pipeline to life. Okay. We want to also harden our OPS samples. We've done some amount of testing, things that we thought of, corner cases and just flow functionality, but we can also improve on those. So please feel free to contribute documentation, components, pipelines, tests, whatever you feel would add value. And then at the end of October, this is Rachel. I mean, she's our community leader. She has the coolest idea. She says, okay, October is our Halloween month. Are there any Gen AI nightmares? Would you like to share them? So please bring those, because those are the things we as an industry have to solve. We can't have an LLM spewing out dangerous things, obscene things, or biased stuff. And if you've encountered some of those things, we need to address them, and let's work together to do so. And many times, especially if it's things like finance or who deserves something, you need transparency in your model, so that explainability angle is just as important. It was wonderful to share with you all about OPEA. I hope you are excited about it and you will get involved. Thank you.